Alright guys, welcome to the second part of this lesson of units, measurements, and conversions. Recall from yesterday's lesson we talked about base units and SI units. We talked about how to convert back and forth between different different sizes of the same unit, so like going back and forth between small units of length like millimeters and big units of length like kilometers and hectometers and things like that. So we did that by moving the decimal to the right or to the left based on our little acronym for our prefixes, which was King Henry doesn't usually drink chocolate milk. So those were the first type of unit conversions that we did yesterday. And if you forget, go back to yesterday's video. It'll be posted on this same page just a little bit above. It's part 1, where we talk about those things. Okay? But today we're going to finish up this section. This is, like I said, part 2, where we do conversion factors and dimensional analysis. This will help us do unit conversions that are a little bit more difficult than just simply moving the decimal to the left or right a few times. Okay. So number one, first thing, go ahead and put your phone away and complete the bell ringer in Canvas if you haven't already done so. So pause the video, do that, and then come back once you're finished. Okay. Number 2, go ahead and join this presentation by going to joinpd.com and using the code here at the top right, the HKYSN. Okay, so join the presentation, type in that code, that way you can follow along with us, answer any questions that the presentation asks you. I can give you feedback as we go. This is a mandatory step, so go ahead and pause right now, do that, and come back whenever you're finished, okay? And then finally, step 3, go ahead and get out paper and pencil to write down some notes, to write down any questions that you may have so that you can ask them later, especially if we're doing this live in a virtual class via Microsoft Teams. Writing down questions so that you can come back in the meeting and ask those is key. All right, and then you will work example problems as well. Alrighty, so let me move my face out of the way here so that I can click through this. Okay, so again, this is still Module 0. We're still talking about measurement, and today is part 2 of Section 5, Units, Measurements, and Conversions. So I'm going to jump ahead because everything that I talked about yesterday you can find in the part 1 video, and we are going to pick up right here on slide number 32. So go ahead and on your screen get to slide 32. That way we can get started and be together, okay? Alright, so on slide 32 we start talking about conversion factors. And so if we remember yesterday, again, moving our decimal to the left or to the right is how we were converting back and forth between metric units, between things like centimeters and meters or millimeters and kilometers. Just moving our decimal to the left and right, but not all unit conversions are going to be that easy. And for those more difficult unit conversions, we use something called a conversion factor. And a conversion factor is just a ratio or a fraction of equivalent measurements. So one example of this might be if I'm converting back and forth between dollars and quarters or dollars and dimes or nickels, I have some conversion factors that I can write. So $1 is equal to 4 quarters. 4 quarters is equal to 10 dimes. 10 dimes is equal to 20 nickels, and 20 nickels is equal to 100 pennies. And I can pick any of these values because they're all equal to each other. They're all representative of $1. I can pick any of these two values and make a fraction out of them. So I can have $1 divided by 4 quarters, and that would be a conversion factor because those two values are equal to one another. I could have 20 nickels divided by 10 dimes, and those two that conversion factor, both of those values are equal to each other, so that's valid. Okay? I can have 100 pennies divided by $1, or I can have $1 divided by 100 pennies. So any combination of these, since they're all equivalent to one another, is a valid conversion factor. Okay? Alright, so let's go to the next slide. So when a fraction contains two equivalent quantities, the value of the fraction is 1. Right? So any number or quantity divided by itself we know is equal to 1. If we just do this with numbers, 10 divided by 10 is 1. 30 divided by 30 is 1. 5 billion divided by 5 billion is 1. And so it's the same with quantities that are equivalent to one another. So if you look down here, we know that 100 centimeters and 1 meter represent the same unit of length, represent the same distance. So since they represent the same quantity, if I divide those by one another, that's equal to 1. Okay? And same if I flip it. 1 meter and 100 centimeters. Those are equivalent measurements, so if I divide those by one another, it's equal to 1. Okay? And we would write these conversion factors to convert between meters and centimeters. We're going to do a lot of examples on this, so if this isn't making sense yet, don't worry. Hopefully it will click whenever we start working some problems out. Okay? So go ahead and look at this picture above. So the figure above illustrates just another way to imagine or look at the relationships in a conversion factor. Meters is a larger unit than a centimeter. Like 1 meter represents about 3 feet, whereas 1 centimeter is about, yay big. So a meter is obviously the larger unit. The larger unit is always paired with the smaller number. Those kind of balance each other out, and they make sure that the top of your fraction and the bottom of your fraction are always equivalent measurements. Okay, and then of course the larger number is paired with the smaller unit. So again, it's just a balancing act. So that's just one way you can look at these relationships to show that they're going to balance each other out and be equivalent. So you can see 1 meter up here represents the same distance or the same unit of length as 100 centimeters, right? So 1 meter divided by 100 centimeters, since they're equal to each other, is 1. All right, let's move on to the next slide here. Okay, so now that we know kind of what a conversion factor is, we're going to talk about what dimensional analysis is. So dimensional analysis is a way to analyze the units of a problem and solve that problem using those units and kind of manipulating the units in such a way that they're going to cancel each other out and leave you at the end with the units that you want your answer to be in. So it's just a way of solving problems by using the units instead of so much as using like a formula or something like that. It's kind of like solving a puzzle. Okay, so we can use dimensional analysis and conversion factors to solve many problems in chemistry. As a matter of fact, we're going to do this pretty much all semester. It might not start right away. It might start like more towards module 3 or 4, but we're definitely going to be using dimensional analysis for at least half of the semester in this class. Okay, so it's important that we get it now so that we don't have to relearn this down the road. Okay, so if you have questions, this is an important lesson to ask those. Alright, so your goal with dimensional analysis is to use one conversion factor or multiple conversion factors in a certain order in order to convert from one unit to another. And remember that a conversion factor is just a fraction with equivalent quantities on top and bottom. So like 4 quarters divided by 100 pennies, they represent the same amount of money, so they would be a conversion factor. Okay, now let's go to the next slide. So it says to take advantage of cancellation rules when multiplying fractions. So remember, cancellation rules with fractions. If you have something on the top of a fraction and something on the bottom of a fraction, and they're the same, they cancel each other out. And that applies to units. So if I have units of grams on the top of a fraction, and then over here I have units of grams on the bottom of a fraction, those are going to cancel each other out and go away. Okay? So if you want to convert away from a unit, you want to cancel that unit out in your setup of your problem. So if you're wanting to convert away from a unit that's on top, you're going to want to put that unit on the bottom of a conversion factor. That way it'll cancel it out and you can get away from that unit. Okay. In all of these problems, we're going to multiply our starting quantity. So whatever unit that we start with that we want to get out of, we're going to multiply that quantity by 1. Because remember, all conversion factors are equal to 1. So we're going to multiply our starting quantity by 1. So we're not actually changing the quantity. We're just changing the units that it's expressed in. Okay, so we're going to see what that looks like. And I know that this can be kind of confusing just to talk about, but hopefully whenever we start working examples, you'll see what I mean. Okay, and so one example of this might be how many seconds are in a workday that lasts exactly 8 hours. Okay, so I have 8 hours. That is the unit that I start with and that I want to get away from. And then I want to know how many seconds. That's what I want my final answer to be in. So what do we know? Well, we know that 1 hour is 60 minutes. And we know that 1 minute is 60 seconds, right? And then we know that I worked for 8 hours. And what do we want to know? We want to know how many seconds. So, okay, there's the answer. But before I just show you the answer and move on, I want to show you what this will look like worked out. So I'm going to go to the whiteboard. This is slide number 37. Okay, so let's go 37 here. And let me move my face back over here. That seems appropriate. All right, so my goal here is to take 8 hours and turn that into some number of seconds, right? That's my goal. So here's all the information that I'll need. I'm going to need to write some conversion factors. So this is how we do dimensional analysis. Remember, I'm just going to take my starting quantity and I'm going to multiply it by forms of 1 by conversion factors. And it can be one conversion factor or it can be multiple conversion factors. But I'm going to set it up as if I'm multiplying by a fraction. Okay? And so my first step is I want to get rid of hours. I want to cancel hours out because I'm trying to convert away from it. That means that I want to have hours on the bottom of my first conversion factor. Okay? So if I want to have hours on the bottom of my first conversion factor, then out of these two conversion factors, I'm going to choose the top one because it's the only one that has hours in it, right? So I'm just going to put hours on the bottom, so that's 1 hour, and then 60 minutes on top. Okay? And remember that 60 minutes and 1 hour represent the same amount of time. So this fraction is equal to 1. I'm really just multiplying 8 hours by 1 and expressing it in different units, right? So hours are going to cancel out. And my question is still not answered, because if I did this as it is, my final answer would be in minutes, and I don't want that. So I need another conversion factor. Okay? This time, I want to convert away from minutes, so I'm going to put minutes on the bottom of my conversion factor to cancel it out. And then that means I'm going to choose the second conversion factor here. So 1 minute will go on the bottom, and then 60 seconds will go on top. Okay, now minutes will cancel out because there it is up top, here it is on bottom, and again, 60 seconds divided by 1 minute represents the same amount of time. So that fraction evaluates to 1. Okay, anytime I multiply by a conversion factor, I'm really just multiplying by 1. But it will allow me to express my quantity in different units. Okay? So now my problem is set up. All I have to do is multiply my numbers together. I'm going to have 8, and I'm going to multiply by everything on the top, so times 60, times 60, and then I'm going to divide by everything on the bottom, divided by 1 times 1. Okay? And when I do that, 8 times 60 times 60, ooh, that got right, is I think 28,800 divided by 1. Okay? So now my final answer is 28,800. And then my units, don't forget those, my units are seconds, because I've canceled everything else out. Alright, so that's how I would set up my first dimensional analysis problem. And it seems really lengthy because I'm sitting here explaining it at length, but once you get used to this and get a little bit of practice with it, this is a very quick and easy process. Okay, so just take some practice. We're going to work a few more examples here in a bit. Let's go back to our slides. Okay, so again, that answer was 28,800 seconds. Alrighty, so that's it with the slides. I do want to work a few more dimensional analysis problems. That way you can see a few more examples. So go ahead and tell me which of the following is the SI base unit for mass. Pause the video, answer the question, and then once you're done, unpause, and I'm going to move on right now. Okay, so if you said kilogram, great job. That's a review from yesterday's lesson from part 1. Then the second question is, what is the relationship between mass and volume called? Remember, we talked about this yesterday as well. So something was equal to mass divided by volume. So go ahead and pause, answer that question. Unpause when you're finished. I'm moving on right now. And if you said A, density, then great job. Looks like you got it. Okay, so go ahead and take this time to ask any questions. You can do that on your slide. And meanwhile, I'm going to go over back to our whiteboard. And I'm just going to find some more example problems to work for dimensional analysis because I know I have them here. All right. Here we go. So let's look at some of these here at the bottom. Okay. So it says to write conversion factors that relate days to weeks. So this time I'm just going to write conversion factors. I'm not even solving a problem. I'm just going to do a few of these. Ready? Okay, so write conversion factors that relate days to weeks. Well, what do we know about how many days there are in 1 week? What are some measurements there that are equivalent? So 1 week is equal to 7 days, right? So remember that a conversion factor is a fraction. And I can write two fractions with these numbers. I can have weeks on top or I can have weeks on bottom. So my conversion factors would be 1 week over 7 days, or 7 days over 1 week. Alright, so these are two conversion factors that represent the same unit of time. Both of these are equal to 1. Okay, both of those are equal to 1. So if I was doing a conversion between weeks and days, I might use one of those to multiply and convert my units, right? So next one says write conversion factors that relate feet to miles. So you might know that 1 mile is equal to 5,280 feet. Okay? And so again, I can write two fractions. I can put miles on top or I can put miles on bottom. So my conversion factors would be 1 mile over 5,280 feet, or 5,280 feet over 1 mile. Okay, and remember that both of those fractions, since they represent distances that are the same, both of those fractions are equal to 1. So I'm not going to do 3 and 4. You're welcome to pause the video and see if you can write conversion factors that relate feet to yards. Remember, 1 yard is 3 feet. And then see if you can write conversion factors that relate millimeters to kilometers. And so you might not know that conversion right off the top, but if you know that 1 meter is equal to 1,000 millimeters, and if you know that 1 kilometer is equal to 1,000 meters, then you may be able to work out a couple of conversion factors there. So give these two a shot. You can pause the video, answer those just to get a little bit extra practice. But now I want to work out 1 or 2 dimensional analysis problems. Okay? So let's do that. Let's do that. This shouldn't be too bad. Okay. Alrighty, so number one is asking us, an experiment is done to see the health effect of large amounts of aspirin on rats. Each rat gets 22 grams of aspirin. If 60 rats are used in the experiment, how many grams of aspirin are used? Okay, so they tell me that 60 rats are used, and they want to know how many grams of aspirin will be used. So this is a conversion factor, a dimensional analysis problem. I have 60 rats, and I want to convert that into grams of aspirin. And so in order to do that, I need a conversion factor. So that is also in my problem. It says each rat gets 22 grams of aspirin. So the relationship there is 1 rat equals 22 grams of aspirin. Okay, and the conversion factors that I could write, I can either put rats on top or rats on bottom. So I can say, 1 rat over 22 grams of aspirin, or 1 gram of aspirin over 1 rat. And let me scoot this over there so you can see what I'm writing. Okay, so those are 2 conversion factors that I could write. Here's number 1, here's number 2. Alright, so now to solve this problem, I'm going to say, alright, I have 60 rats. That's what I start out with. I need to choose a conversion factor from above, either number 1 or number 2, that's going to get rid of rats and give me aspirin, give me grams of aspirin. So I have rats to start. That means that I want to cancel it out in my conversion factor. And to cancel it out, I need to put rats on bottom. Okay? And I have a low battery, so hopefully I finish this video really soon. Alright, so I need to put rats on bottom. So the only one of these that has a conversion factor with rats on bottom is number 2. So I'm going to say 1 rat, and then I'm going to put 22 grams of aspirin on top. Okay? Alright, so now look, my units, rats cancels out. My final answer will be in grams of aspirin. So now just evaluate. 60 times 22 divided by 1. Okay, and 6 times 22 is 132. Tack the 0 on there. So 1,320 grams of aspirin is my final answer. Okay, 1,320 grams of aspirin. So that was a dimensional analysis problem. Let's do one more. Let's just do one more, and then I will turn you loose. Let's do number 2. Okay. Alright, so number 2. It says apples sell for 43 cents a pound. Okay. How much do 3.2 pounds of apples cost? So I have 3.2 pounds, and I want to know the cost. I want to know how many cents that's going to be, or dollars and cents, right? So I know that 1 pound is equal to 43 cents. I got that from the problem, right? Apples sell for 43 cents per pound. So if I want to solve this problem, my conversion factor will come from this 1 pound equals 43 cents, and then I'll just set it up just like I did the rats problem. So 3.2 pounds. I'm going to multiply by a conversion factor. And remember, all conversion factors are equal to 1. So I'm not actually changing my quantity. I'm just expressing it in different units. Okay? So again, I start with pounds. I want to get rid of pounds, cancel it out. So I need to put pounds on the bottom because it starts out on the top up here. So I'll have pounds on the bottom. And so my conversion factor is here. 1 pound goes on the bottom, and then 43 cents goes on the top. Okay, and I'm not even going to pretend to know what that is off the top of my head. But to evaluate that, I will do 3.2 times 43 divided by 1. Get an answer. You know what, let's see if I can do this off the top of my head. Let's see how good I am. It's 129 plus 8.6. I think it's 137.6. Y'all can check me. Make sure my math is right, because I don't have my calculator nearby. Alright, so 137.6. And this should be cents. Okay, and that's your final answer. If you really want to, you can convert this to like $1.37. But you don't have to do that. This could be your final answer, the 137.6 cents. Alright, so there were 2 dimensional analysis problems. I know it took up kind of a lot of writing, a lot of space here, but why don't you try number 3 and number 4 on your paper, and I think that'll be good practice for you. And if you have any questions, please let me know, because this is a very important skill that we're going to use a lot, especially later in the class. Okay, so I'm going to cut it off here. The assignment is going to be due tomorrow, so make sure you complete that and then complete your exit ticket, and then we're done for today. Okay, so thank you guys for watching. I hope this made sense. If you have any questions, let me know. I'm going to go ahead and sign off. I'll see y'all later.